Thank you so much for joining this lesson. We'll be discussing the Premium Joint Examination in preparation for the Kcse 2025. So this is the October 2025 post-mock, a very good paper. Remember, you can consult us through 0704 15 33 66. Feel free to reach out. The paper is very interesting, a well thought out paper, and I'm sure by going through this one, you guys will be well equipped. Remember to subscribe, remember to share so that you may invite other friends. Just as we continue, please allow me mention our programs here. We're calling it the One Term Ahead program, whereby over the November-December holiday from the 20th of November to 12th December for 5 good weeks, we shall be having a powerful program via Google Meet. We'll be covering the term 1 work of 2026. So the students and learners in junior school who are still continuing, who are not doing the national exams this particular year, are encouraged to join us for very wonderful discussions. Our consultation line is just as typed on this particular poster, 0704 15 3366. Invite your brothers, invite your sisters, invite your students, so that we may keep growing together. So please refer them to us. They shall not regret joining Shifting Grades Online School. Solve for x in the logarithm of x to base 3 squared minus half the log to base 3 of x equals to 3 out of 2 for 4 marks, as you can see. So the first thing that we're supposed to do here, when you look at the logarithm of x to base 3, it's appearing at this point and also at this point. So we can let it be a different unknown, say for instance, t. So we can let the log of x to base 3 be something like t, so that now when we re-express our equation, we shall be having t squared minus half the value of t equals to 3 out of 2, like that. Then from this, now we can do away with the fractions and actually have 2t squared minus t equals to 3, which is again not a must. We can proceed and solve this particular quadratic equation using what we call the completing square method. Actually, when we approach it through the completing square method, we are almost done with some steps, because the constant is already to the right-hand side, and the value, the coefficient of t squared, is already 1. So that means we can just proceed to make the left-hand side a perfect square. And how do we make it a perfect square? By remembering that we're supposed to add a constant c, which is given by b out of 2 squared. Therefore, we can rewrite this as t squared minus half t. Then we add a constant here, which is negative half divided by 2 squared. So negative half divided by 2, first, it becomes negative a quarter. Then now we square it. So 1 out of 16 equals to 3 over 2, also plus 1 out of 16. So we add the constant on both sides. So we can, after making now the left-hand side a perfect square, we can now factorize it. To factorize a perfect square means we take the square root of this part, which is t, the sign that follows, which is a minus, and the square root of the constant, which is now a quarter squared. You see? This is now the factorized perfect square. Equals to, we combine on the right-hand side, 3 out of 2 plus 1 out of 16. You know, this gives us 1 and 9 out of 16. 1 and 9 over 16. You know, technically this is 25 over 16. We can actually make it improper. Yeah, 29 over 16. Actually, for the square rooting process, let me make it now, instead of 1 and 9 over 16, we make it 25 out of 16 that way. So with that now, we can proceed to take square root on both sides. T minus a quarter equals to plus or minus. We take now the square root of what we're having here, and it becomes 1 and a quarter, which is 5 over 4. Then how shall we find the value of t? Two options, either the positive part of the square root, then we add the quarter which is on the left, it becomes positive, or t equals to the negative square root, we also add a quarter to it. Therefore, this shall be 6 over 4, right? 5 over 4 plus 1 over 4, giving us 1.5. Yeah, 1.5, or 3 over 2. Or t equals to negative 5 over 4 plus 1 over 4. This gives us negative 1. So we have two possible values of t. Two possible values of t. We're already having the values of t now. We can get back to what we had let to be t. What had we let to be t? The logarithm of x to base 3. So the log of x to base 3 equals to 3 over 2. We can get the first value of x. Remember, we're supposed now to change the statement from logarithm to index notation for us to get the value of x. In case you given, this is now general, in case you given the log of b to base a equals to c, then it means when we take 10 power c, we're supposed to get the value of b. Now, this logarithm statement can be changed to index notation. A power c should give us b. That's why when we say the log of 1,000 to base 10 equals to 3, it means 10 power 3 equals to 1,000. Therefore, a power c should give us b. And from this statement now, we can proceed by saying that 3 power 3 over 2 should give us x. And this implies that the value of x now equals to, we compute these, 3 power 1.5. So 3 raised to 1.5. This gives us 5.196. That is when expressed to 4 significant figures. Again, we can also say that the logarithm of x to base 3 equals to the other value of t, negative 1. So that we also change it to index notation. 3 to the power of negative 1 equals to x. According to the laws of indices, this is a negative power. So you can say the value of x then shall be equal to 1 out of 3. You just take the reciprocal, then the power becomes 1. So a third power 1, remaining a third. Very simple, very good question, very engaging, and you're supposed to be knowing how to flow when you are given such a question. Proceeding to number 2, a question on SURDS. Remember, ladies and gentlemen, you can purchase some airtime of whatever amount you need by simply going to our facility here, whereby you go to Lipa na M-Pesa. The pay bill number is 737356. Then the account number is the phone number that you're purchasing the airtime for. Could be Safaricom, Airtel, Telcom, whatever network, as long as it works in Kenya. Please apply it. Then proceed to enter the amount, complete the transaction, and your airtime shall be reflected instantly. So please make use of our facility here. Involve friends in the same. Just promote our product here by getting yourself airtime of whatever amount for whatever network. You can also use it for a friend, whereby you enter the pay bill then the account number is the number of the friend that you are purchasing airtime for. Such a thing. Proceed now to number 2. Simplify the expression. The expression you can see here, the square root of 96 divided by root 5 plus root 3, leaving the answer in the form where a, b, and c are integers. All right. When you look at the surd on the numerator, it's not fully simplified because with 96, there is even 16 and 6. So we can actually rationalize this particular surd even when the numerator is not simplified. Then we simplify at the answer, or we begin by simplifying the numerator first and now we rationalize. Any shall work. Therefore, now we can talk about the root of 96 being equal to 6 by 16. Is that true? Confirm 6 by 16. Yeah, 96. Therefore, the root of 16 is known and it's 4. But the root of 6 now remains in the brackets like this. So we can have it as 4 root 6. So now we can write, we are rationalizing now 4 root 6 out of the root of 5 plus the root of 3. How do we rationalize the denominator? By ensuring that we multiply both the numerator and also the denominator by the conjugate of the denominator. Therefore, with root of 5 plus root of 3, we multiply this with root of 5 minus the root of 3. Then now the same happens, so that the value of the expression is not tampered with. We do the same here. The root of 5 minus the root of 3, like that. So let's expand the numerator, giving us 4 the root of 30 minus 4 the root of 18. Yeah. Then this should be divided by, now we also rationalize the denominator. It's good for you to know that when a surd is multiplied by its conjugate, we get a rational number. But looking at it technically, what it gives us is what we call a difference of two squares, which has been factorized this way. A plus b, a minus b, like that, whereby according to the quadratic identities in Form 2 mathematics, we say that this is the same as a squared minus b squared. So here, we can say that when this is expanded, we should get this according to quadratic identities. Therefore, we just need root 5 squared minus root 3 squared. So root 5, this should be squared, minus the root of 3 squared, like that. So we'll be having 5 minus 3, in other words. So now we talk about from the numerator 4, the root of 30 minus 4. You know the root of 18, there is 9 by 2 now, which can be simplified further, out of 5 minus 3. So let's talk about 4, the root of 30 minus, you know the root of 9 is 3. So when 3 is found, it is having a 4 already outside, so making it a 12. But the root of 2 remains in the brackets. It remains under the root sign because root of 2 is not known. Out of 2, like that. So with this now, we can do further simplification, whereby we can see from the numerator, 4 is common. So we can remain with root 30 minus 3, the root of 2. Then this is divided by 2. So 2 can simplify. Then we have 2. Let me check. 2 the root of 30 minus 6 Yeah, 6 the root of 2 after the 2 has multiplied there. So we can have this one as our final answer according to the format that they need. According to the format that they need at that point. So that is the final answer. Number 3, the roots of a quadratic equation are x equals to 5/7 and x equals to -2. Form the quadratic equation in the form ax squared plus bx plus c equals to 0, where a, b, and c are integers. Where a, b, and c are integers. Okay. Now we're supposed to know that if x equals to 5/7, then if this equation had been solved to give us the roots using the factorization methods, then the step just before these values of x could have been x minus 5/7 is equivalent to 0, and x plus 2 equals to 0. That's why x is equal to -2. That's why x equals to positive 5/7. Such a thing, you see? So with this now, let's talk about the step just before this one. We must be having x minus 5/7, x plus 2. Now all of them are equal to 0. Then now we can expand the left-hand side. X by everything in the second bracket, -5/7 by everything in the second bracket, giving us a 0. So x squared plus x plus 2x, sorry, plus 2x, then minus 5/7x minus 10/7 equals to 0. Can we do some grouping of terms? Can we do some grouping of terms here? Yes, please allow me to do the same. So we can start with x squared. Then 2x and -5/7, 2 minus 5/7, because those are values of x. We get 1 and 2/7, which is 9/7, x, then minus 10/7 equals to 0. We can multiply through by 7 so that we remain with integers. Look at these, integers, not constants. In case we'd been told that a, b, and c are constants, we would have gotten the final mark at that point. But now that we need them as integers, then we multiply through by 7, making this one 7x squared plus 9x minus 10 equivalent to 0. So this is the final step, and that is the quadratic equation that we needed. Number 4, determine the period and phase angle of the function y equals to 7/2 cosine of 3x plus 40 degrees for 2 marks. We're supposed to know, when given the function, trigonometric functions, y equals to a certain value, then cosine, then another value here times x, plus or minus a certain angle, or the function can be a sine one, a, the sine of, kx plus or minus a certain angle here, like that. With a function like this, then we're supposed to know that amplitude of the wave is given by the value of a, then period of this particular trigonometric wave is given by 360 divided by k, the multiplier of x, then what you call the phase angle. Phase angle is usually given by the absolute value of theta. So if it's minus, we just pick the absolute value. So with this analysis now, we should be able to work out number 4 for the 2 marks by saying that the period equals to 360 divided by 3, giving us 120 degrees. Then the phase angle The phase angle equals to exactly 40 degrees. Just that, you get your 2 marks. So you're supposed to know these analysis. This one should always be in your fingertips. Whenever you're revising for mathematics paper 2, please have that with you. Have that with yourself. Looking at number 5 now, ladies and gentlemen, the data below shows the ages of 10 students picked at random in a primary school. 6, 11, 13, 14, 8, 7, 12, 10p, and 9. If the summation of fx squared equals to 1185, determine the value of p, hence find the exact value of variance for this particular data. Exact value. I'll be mentioning something about that word, exact value, as we continue. Now, the data is here. X is usually the values, the data itself, either midpoints, or if the data is not grouped, the values themselves. Like in this case, we need to know that 6 squared plus, that's why we have this symbol, which means summation of. The 6 that we have are only 1. We have only 1 6. Then we go to 11 also squared plus 13 squared plus 14 squared plus 8 squared plus 7 squared plus 12 squared plus 10 squared plus p squared plus 9 squared. We are supposed to get 1185. Yeah, we're supposed to get 1185. So let me work out this. Everything squared. 6 squared plus 11 squared plus 13 squared plus 14 squared plus 8 squared plus 7 squared plus 12 squared plus 10 squared plus 9 squared. So we are saying that 960 plus p squared equals to 1185, and hence p squared equals to 1185 minus 960, giving us 225. Hence, the value of p should be the square root now of 225, which is exactly 15. So p is 15. We have all the values now. And if we have all the values, in the process of finding variance, the first thing that we're supposed to get is mean. Let's get mean. Let's find mean. So mean means everything added, and we divide by 10. Everything added. So 6 plus 11 plus 13 plus 14 plus 8 plus 7 plus 12 plus 10 plus p, which is now 15, plus 9. We are not squaring them. We are simply finding mean out of 10. So let's get the answer here. 17, 30, 44. I'm adding 6 and 11, 17, 30, 44, 52, 59, 71, 81. Now 81 plus 15 comes 96 plus 9. 96 plus 9 gives us 105 over 10. So 10.5 is the mean. 10.5 is the mean. I hope I've computed it with accuracy. In case I've made a slight mistake, which is very possible, ladies and gentlemen, please correct it and proceed. Yeah, correct and just follow the working kindly. Just follow the working. Okay, with the mean now, we can get deviations. How each value varies from the mean. How each value varies from the mean. So we need now deviations. Deviations which are given by each value minus the mean. How is each value varying from the mean? So let's get deviations. 6 minus the mean, get 6 minus 10.5, I'm getting negative 4.5. 11 minus 10.5, I'm getting 0.5. 13 minus 10.5, I'm getting 2.5. 14 minus 10.5, I'm getting 3.5. 8 minus 10.5, I'm getting negative 2.5. That's after 8. Okay, 7 minus 10.5, we're getting negative 3.5. After 7, we talk about 12 minus 10.5. This gives us 1.5. After 12, we talk about 10 minus 10.5, giving us 0.5 negative. After 10, we go to P itself, which is 15 minus 10.5, I'm getting 4.5. And finally, 9 minus 10.5, giving me negative 1.5. We have all the deviations from the mean. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 values, deviations. So how do we get variance? Variance is usually given by the summation of the square of all deviations. Then we divide them by the total number of values that we are dealing with. So we need all deviations squared and added up. All deviations squared and added up. So 4.5 squared, that is 20.25. Actually, I wanted to add them direct, but let me show the squared values. So 20.25 plus 0.5 squared, we get 0.25 plus 2.5 squared, we get 6.25 plus 3.5 squared, we get 12.25. After 3.5, we add 2.5 squared, 6.25. After that, we add 3.5 squared. You know, I'm saying 3.5. If you discover what I'm doing, if you're careful, you find that I'm omitting the negatives when I'm squaring, just because whenever you square, the negative should disappear. And that's why if you are introducing the negative for squaring, then introduce brackets so that we know that even the negative is getting squared. Negative 3.5 times negative 3.5, the negative will have to disappear. And because the negative is disappearing at the end of the day, then I don't have to waste time introducing it in my squaring part. That's 1.5. Then 0.5, we also square, giving us 0.25. Then 4.5 should also be squared, giving us 20.25. Then there is 1.5 squared to give us 2.25. So it's like I've squared all of them. Then now we'll be dividing everything. We'll be dividing everything by 10. Let me confirm whether the values are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've squared the 10 values. 20.25 plus 0.25 plus 6.25 plus 12.25 plus 6.25 plus 12.25 plus 2.25 plus 0.25 plus 20.25 plus 2.25. This is exactly 82.5 out of 10, and this shall give us 8.25. This is now the variance. Remember, in case you'd been told to find standard deviation, you would have followed the same procedure, but you know that standard deviation now is the square root of variance. Standard deviation is the square root of variance. Something else that you also have to master is that you can also be told to find mean absolute deviation. Mean absolute deviation means you add the deviations by taking their absolute values, then you divide by n, divide by the total number. So you add in the deviations that we got, we now add them regardless of the sign. We add absolute values. To get mean absolute deviation, you add deviations as the absolute values. If it's negative 4.5, you just take 4.5 like that. You add all the absolute values, then you take their mean. You'll have gotten mean absolute deviation. At number 6, ladies and gentlemen, now the position vectors of points P and Q are 3i, negative j, minus 4k, and 8i, minus 6j plus 6k, respectively. Then a point R divides PQ in the ratio 2:3. Find the position of R. This is internal division. Proportional divisions of lines, we have what we call internal division. Like in our case here, if we have P here, then we shall have our point R, which divides P, then Q comes here, like that. Therefore, the position of P is known. This is 3, -1, -4, according to the position here. Then again, for Q, we have 8, -6, and 6. Then now R is dividing in the ratio 2:3. When we apply the ratio theorem here, those who have been following my presentations, they know that we've been applying ratio theorem in most of the questions in section A, even when the scale factor is negative. Yeah, even when the scale factor is negative. Therefore, now, when we pick the ratio of 2 out of the total proportions that are 5, then we multiply by, when you pick 2, you use the opposite vector, which is Q. 8, -6, 6. Then we add the ratio 3. When you pick 3 out of the total proportions 5, we should multiply by the opposite vector to 3, to the ratio of 3, which is P. 3, -1, -4. This now should give us the position of R. Yeah, so let's compute this to get the position of R. 2/5 by 8, that becomes -16. Okay, 16/5 plus 9/5. 16/5 plus 9/5. That should give us the x coordinate. We proceed. -12/5 plus -3/5. That should give us the y component. Then the z coordinate shall be +12/5 minus z12 still over 5. Yeah, look at that. Just look at that. So I'm multiplying every ratio here by all the components. If it's 2/5, I multiply it by 8. 3/5, I multiply it by 3, like that. So all these now, after I've opened the brackets, all these should give us R. So let's proceed. 16/5 plus 9 over 5. This gives us exactly 5. Next, negative 12 over 5 plus negative 3 over 5 also. We get negative 3. The next shall be 12 over 5 minus 12 over 5. That becomes a 0. That one becomes a 0. This now gives us R. If that gives us R, then we can proceed to find the position vector. The way the position vectors of P and Q had been expressed, we also expressed for R. So for R, then the position vector or R shall be 5I minus 3J. The K part is a 0, so you don't have to write 0K. So that is the final answer, final expression of the position vector of R. So that is it. That is it. A very good question. Very good question. You can visit more on vector 2. You can also check the cases where we do collinearity. You know, vector 2 is highly predicted this year. So we can check the proportional division of lines or the collinearity, showing that 3 points are collinear. A very simple task. Let's look at number 7. Thank you for joining us. There are those who are joining us late. Remember, our consultation line is 0704 153366. Remember our wonderful programs here for the November, December, August, December holidays. From the 10th of November to the 12th of December, 5 good weeks via Google Meet interactive forums covering the 2026 Term 1 work. We are targeting the junior school and also the senior schools. Kindly enroll. Ensure that you enroll to our programs so that you may get the best from the best. Our number is attached on the poster 0704153366. So feel free to join us for the wonderful programs. Number 7, this is a probability question. Let's check what it says. Now, 3 teachers are chosen at random from a staff consisting of 5 men and 7 women to attend a CBC retooling exercise. Using a tree diagram or otherwise, find the probability that the retooling consisted of all women from the staff, and also 2 of the retooling attendees are men from the staff. We can begin by first plotting the tree diagram, whereby we say in this particular staff room, there are men and there are women. So in the first picking of the member, we can be picking a man or a woman. Now to pick a man, it means 5 out of 12 because the total is 12. Then 7 over 12 for women. Then I don't know why women are always the majority almost in everything. You can see this is a particular staff room where women are 7 and men are only 5. Now, once you pick a man, in the second selection of a member from this tab, you can still pick a man or a woman. But now picking a man should take a probability of, because you've already picked a man, they are now 4 out of the new total, which is 11. But this one remains to be 7 over 11. Then in this case, whereby we picked a woman, we can, in our second case, pick a man or a woman. Now, picking a woman again, the probability should go down to 6 now out of the new total, which is 11. But for men, it should be 5 over 11. We continue expressing. I don't know whether the space shall allow us to have a well-displayed tree diagram. There are 3 members, and still have man, women. So we shall consider the previous very keenly. If you had picked a man, picking a man for the 3rd time, now it goes to 3 out of the new total of 10, meaning that this is 7 over 10. If you had picked a woman, you can pick a man or still a woman. Now, picking a woman again, when the probability was 7/11, it is to become 6/10, meaning that for men, it is 4/10. I'm squeezing the values there, and I hope you will understand them. When you picked a man here, you can pick a man again or a woman. Now, if the probability of picking a man was 5/11, then in the next selection now, picking a man should go down to 4 out of the new total of 10. Then women should be 6/10. If you had picked a woman here, you can pick a man or still a woman again. Now, if picking a woman was 6/11, picking a woman again in this third case should be 5 out of 10, meaning that for men, it remains 5/10, like that. So we have all the possibilities displayed here. Allow me now at the end of the brackets now outline all the possibilities. The one ending with this M is man, man, man. The next, the one ending with this W is starting with man, man, then woman. The one ending with M here is starting with man, woman, man. The one ending with the W here is man, woman, woman. Then now we can go to this one, woman, man, man. The one ending with W here starts with woman, man, woman. The one ending here with M, it's woman, woman, and a man. And finally, the one ending with a W here is woman or through, like that. So you can see the outcomes have been outlined at the end of every branch. When you're taught to draw a probability tree diagram, it's not a must you outline all the possibilities at the end, but for your own convenience, I find it very good to have all the possibilities well outlined. Now let's get to the responding part A. The retooling consisted of all women from this stuff. So it means probability, the 3 people being woman, 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 which is 7/12, 6/11, 5/10. So now we can compute these. 7/6/5 out of 12/11/10. Now this will give us 7 out of 44. That is the probability. Remember, probability can be expressed as a fraction, as a decimal, or as a percentage. Just before I forget, there's something I was saying here. We were to find the exact variance. 8.25 was the exact variance. Now, I gave it as a decimal because it's a terminating decimal. I didn't have to round it off. That is the exact value. In case you find that you're finding the variance, then the value is even filling the screen of your calculator and you have to round off to for significant or something, that is not an exact value. It would be better if you prefer the fraction. So when we say exact value, it means either the word exact value, it means either a terminating decimal, a terminating decimal, or a fraction, yeah, or a whole number. So if you don't get a whole number, exact value means a terminating decimal that you don't have to round it off. Like the one we have here, 8.25. It was just exactly that way. Or if you find that you have to round it off for you to have it expressed, then please prefer the fraction part of it. That's the meaning of exact. You don't have to round off. Exact means exactly. Part B. 2 of the retooling attendees are men. Probability that we have 2 men. Probability that we have 2 men. So that we get 2 men, For us to get to men, we need a chance like this one. Men, men, then woman. Or men, woman, then man again. Or this one. Yeah. The chances where men are 2, they are only those ones. 2 of the retooling attendees are men. So it's probability man, man, woman, or probability man, woman, man again, or probability woman, man, man. Yeah, like that. I don't think whether there is an option that I'm leaving out. Yeah, I think those are the cases. So in the first case, we need a probability of 5/12 by 4/14, 4/11, then woman, which is 7/10. Or in probability means addition, man, 5/12, woman, 7/11, then man, once again, 4/10. 4/10, this one. So I'm picking the probabilities there. And finally, we need to add 2. We start with a woman, 7/12, then man, 5/11, and man again, 4/10, like that. So this is the probability that we are finding. This is the case that we are working out. 5/12. Allow me working it out, actually. Allow me use one step. These are only 2 marks. So once you express like that, we should expect you now at the answer point. 5/12 by 7/11 by 4/10. Then plus, we start with 7/12 multiplied by 5/11 multiplied by 4/10. So I'm getting 7/22. Like that. When the marks are only 2, you try as much as possible to save time, because after the method mark, we should expect you now at the accuracy mark. As long as you're very accurate, you open your brackets very well, kindly use one step in such a case. Number 8, this is on variations. A quantity P varies partly as the square of Q and partly as R. So this partial variation, because of the word partly. When you just hear the word partly appearing, that's on partial variations. We are told that when P is 3.8 and Q 2 and R equals to -3. When P is -0.2, Q 3, R is usually 2. Find the value of P when Q equals to 10 and R equals to 4. The first thing that we're supposed to do here, we're supposed to write an expression, a general one, connecting P, Q, and R this way. P is varying partly as the square of Q. Look at that, square of Q. Square of Q. Some other times a student will see the word square, but they'll end up expressing square root. It's good for you to underline the key terms as you continue working out. The other part as R, just as R. So we can do away with the symbol of proportionality here by introducing 2 constants. Whenever we are dealing with partial variations, constants are usually 2. So P equals to a constant times R squared and another constant to multiply R. In this case, K and C are constants. We're now supposed to use the provided conditions here to find the exact values of the constants. P equals to 3.8. When Q is 2 and R -3. So if R is -3, we square it. It becomes 9K plus when Q, what did I write here? Sorry. This is supposed to be Q. Sorry. The square of Q. The square of, sorry for that. The square of Q like that, yeah. The square of Q. So 3.8, that is the value of P. Then square of Q. You know Q is a 2. So squaring Q makes it 4. Okay. R is -3. So -3 multiplied by C. That is the first equation. The second equation should be P is -0.2. When Q is 9, so squaring Q is 3, so squaring it makes it 9. And R is 2 by the value of C. So we are now having the two equations which are supposed to be solved simultaneously. We can use a variety of methods of solving simultaneous equations, and kindly allow me prefer, no, this is equation 1, this is equation 2. Allow me prefer what you call substitution method. We can have 2C there, then we have -0.2 minus 9K. So to remain with C, we divide through by 2. -0.1 minus 4.5K. So now we take this one to equation 1 because this is from equation 2. If this is from equation 2, it means we can now rewrite equation 1. And where there is C, we substitute 3.8 equals to 4K minus 3 instead of C, like that. Remember, I've been talking about solution of simultaneous equations, solution of quadratic equations. For both paper 1 and paper 2, we can't avoid those type of equations. We shall solve them even in topics that are very independent topics. So 3.8 equals to 4K. This becomes positive 0.3. Then again, positive 4.5 by 3, positive 13.5K. When I join the K's together, I'll be adding 4 here to make it 17.5K. Then on the other side, 3.8, I subtract 0.3. Now this will give us 3.5. And for us to get the value of K, we should talk about 3.5 out of 17.5. That is 1/5, or rather 0.2. 1/5 or 0.2. That's simple. That's simple. At this point now that the value of K is known, we can get back to this expression and find C. C shall be given by -0.1 minus 4.5, 0.2. So C shall be -0.1 minus 4.5 into 0.2. Now this gives us -1. Exactly -1. Now with the constants already found, we can see that there is a specific equation that now connects P, Q, and R. That equation now shall be this one. P equals to the value of K, 1/5 multiplied by Q squared minus 1, the value of R. So this is now the specific equation. With the specific equation, C is -1. So that's why before R, we have a negative. Then now we are finding the value of P when Q is 10 minus the value of R, which is 4. So 1/5 into 10 squared, then minus 4. This gives us exactly 16. So that's how we work out question like number 8. Yeah, thank you for following. We are now at number 9. We're moving. Remember our consultation line 0704153366, like that. That's our consultation line. Please feel free to reach out. Number 9, the vertices of a triangle T, A 1 2, B 4 2, and C 3 4. Then the vertices of triangle T prime, the image of T, are A prime, half 1, B prime 2 1, and C prime 3/2 2. Determine the transformation matrix M, which is A B C D, that maps T onto T prime. Okay, this is on matrices and transformations, and we know that a matrix multiplied by object should give us image. When this is known, then we will say that the matrix unknown, when this multiplies, you know, the A, the B, and the C should be made now column vectors 1 2, and B 4 2, and C 3 4, like that. We should get A prime, B prime, C prime. This is a, let me use it as 0.5, 1, 2 1, 1.5 instead of 3/2, 2, like that. Let me use it that way. With this, now we should be able to find the unknown values or the unknown elements in this particular matrix. We know that the multiplication happens by, if it's row, we multiply by column to get the first element in the answer matrix. Therefore, A by 1 and B by 2. That's A plus 2B. This should give us 0.5 as one equation. We can also try to form another equation in terms of A and B. So the same row times the next column should give us the next term on the answer matrix. So 4 by A and 2 by B should give us 2, like that. So we have equation 1 and equation 2. Equation 1 and equation 2. We can solve them simultaneously by eliminating B. Look at the coefficients of B. They are already equal. If the coefficients of B are equal, then we can subtract downwards. A minus 4A, we get negative 3A plus a 0 there equals to 0.5 minus 2. We get negative 1.5. So the value of A shall be, when we divide this by negative 3, ladies and gentlemen, I'll be having 0.5, or simply half, as the value of A, meaning that the value of B can now be found. We go back to the first equation and say half plus 2B should be equal to half. So 2B equals to 0, and the value of B is 0. So we have B and A already found. Let's check. The second row in this, the second row, whereby we need to talk about this row times the first column. So C by 1 and 2 by D. C and 2 by D. This is supposed to give us the first answer on this side. And therefore, this gives us 1. Then the same row by the next column. So 4 by C and 2 by D should give us the next answer, which is still a 1. We can solve this one again simultaneously by automatically eliminating D. When you eliminate D, because the coefficients are already the same, we shall get negative 3C plus a 0 equals to 0, because I'm subtracting here. So C equals to 0 then. And if C equals to 0, D can be found. Equation 1, 0 plus 2D is giving us 1, meaning that the value of D is half. So with CD, AB, we can now write our matrix M as the value of A, half, the value of B, 0, the value of C, 0, value of D, half. So that is the matrix of transformation, which was responsible in mapping T onto T prime. Very good question. Number 10, let's look at number 10, ladies and gentlemen. The figure below, or the figures below, show two chords of a circle and a point Q outside the circle. Two chords of a circle, a chord AB and a chord RP. Using a ruler and a pair of compasses only, look at that, a pair of compasses only, draw the circle first. Then you construct a tangent to the circle from point Q. So we have the construction of the circle first. We don't know the center of the circle, but what are the things that we know about circles? In case a chord is bisected, that bisector of the chord, if it's perpendicular, it shall pass through the center of the circle. Therefore, when we bisect chord AB and also chord PR, those bisectors which are perpendicular to the chords shall meet at a point, and that becomes the center of the circle. Therefore, you stand at A, stand at point A, and using a reasonable radius, you make arcs on these sides. Then stand at B using the same radius, you cut those particular, arcs. So one thing that you're supposed to be sure about is that the perpendicular bisector shall enable us to identify. Shall enable us to identify. So this bisector now passes through the center like that. So it shall pass through the center of the unknown circle. We are supposed to do the same for RP. So you stand at R, you make arcs on both sides. Then standing at P and the same radius, you cut the same arcs so that you may bisect. Once this one is bisected perpendicularly, it shall pass through the center. Yeah, it shall pass through the center. So if bisector 1 and bisector 2 here are both passing through the center of a circle, then it means wherever they are meeting, that is the center of the circle. So now this is the center of the circle now, center of the circle. Now, if these are chords, then the circle should now touch A, B, P, R like that. All the points should be touched because chords of circles usually touch the circumference of the circle. Just a minute. Follow keenly. Check what we're doing. Check what we're doing here. Want to curve it so well, such that want to curve it so well and slowly. Yeah, something like that. So that's how the circle should behave. It's not exact. Just know that because of lack of some proper instruments for use on the screen, we just trying to, we're trying to manage seeing the freehand like that. So we are having the circle now, but technically you can understand from wherever you are now, you can see what we are doing. So with this now, we should know that the next thing is to construct a tangent to the circle from point Q. So constructing a tangent to this circle from Q, actually a tangent, we just need one. Remember, we can construct two tangents from a common point, but at least we need one in this case. So the first thing is to join Q to the center. Join the external point Q to the center. Then now bisect QO. Bisect QO. The next step should be bisecting QO. Bisecting QO. Bisecting QO. So you stand at Q, you make an arc. Also make an arc here. Then standing at O, you cut those arcs. So you should be able to identify the mid like that. We can even call it point X. Yeah, point X like that. Therefore, after you've bisected QO, now you stand at the mid and using radius OX, you make arcs on the upper side and also on the lower side. You can make an arc here and also an arc on the lower side like that. After making those arcs now, you can now join the arcs to point Q. You will have gotten your tangent. Like that. You see? So now we are having tangents. We just needed one, but when you construct even the second one, there is no problem. So now the tangent is already drawn, or the tangents like that. So basically, the concept that you add to be knowing here is that when chords are bisected, the perpendicular bisectors of the chord usually pass through the center. So the first bisector, it passes through the center. The second bisector also passes through the center. The center was unknown. Then it has to mean that the point where they are intersecting now has to become our center for the particular circle. So that's how we do it. Look at number 11, ladies and gentlemen. We've been told to expand and simplify. Expand and simplify x minus y raised to the power of 5. Those are binomial expansions and expressions. So we're supposed to know that the first thing to come up with is the binomial coefficients of power 5. So the binomial coefficients of power 5 are 1, 1, 5, 10, 10, 5, and 1. The 6 binomial coefficients of power 5. So now we start expanding. With 1 here, we start with x raised to power 5 at negative y to power 0. But in the next term, x goes to power 4, it's negative y, takes power 1. X goes to power 3, it's negative y, now becomes squared. X goes to power 2 as negative y becomes cubed. X goes to power 1 as negative y goes to power 4. Then x takes a power 0 as negative y ascends to power 5 like that. Now we can expand these. 1 times x power 5. Anything power 0 is 1. So this will be 1 and x power 5, making it simply x power 5. In the next, this is 5 times x power 4. Anything power 1 remains the way it is. So it introduces a negative here. 5, x power 4, and y. Then this one has to automatically become positive. Reason being, when we square, we're raising to power 2. So the negative disappears after we square. Because negative y times negative y, it becomes positive y squared. So now we'll be having 10 x power 3, and y is now squared, minus negative y power 3 becomes negative y power 3. The negative remains. But when powers are even, for every negative, there is another one to cancel it. When the power is odd, there is a negative that remains, affecting the whole number, you know. So 10x squared, now y power 3. Then this is positive because now there is an even power for the negative term, negative y power 4. It becomes positive y power 4 because for every negative, there's another one to cancel it. So 5x power 1 and 4 power 4. This becomes 1. Anything power 0 is 1. So you just remain with y power 5 because x becomes 1. That's the expanded. That is the expanded function. Use the first 3 terms. Okay. So we are expanding fully. I want people to get instructions here carefully. The expansion was full, but now in the application, we are using the first 3 terms. So don't see part C saying that the first 3 terms, then you think we are expanding up to the 3rd term. No, the expansion is full, fully expand. To estimate 9.8 power 5. So you say 9.8 power 5 equals to x plus y, so power 5. So 9 power 8 equals to x minus y, like that. So we can split this one into, the nearest whole number to 9 is 10. Then what do we subtract from 10 to get 9.8? So 10 minus 9.8, this becomes 0.2. This is now the expression. This is now the expression that I wanted. So with this expression now, you can say x can be treated as 10, y as 0.2, because negative 0.2 becomes negative y, like that. Then with that now, we can just substitute now. So x is 10 power 5. I'm substituting in the first 3 terms. Minus 5, 10 power 4, and 0.2, then plus 10, 10 power 3, and 0.2 squared, like that. So we compute this now. 10 power 5, that's 100,000. Then minus 10 power 4 times 5 times 0.2, giving us 10,000. Then we're having a plus 10 power 3 is 1,000 times 10. So 1,000 times 10, 10,000. Then times 0.2 squared, 400. We get 400 like that. So 100,000 minus 10,000 plus 400. This gives me 90,400. 90,400. So that is the value that I'm getting. When you compute in your calculator 9.8, just write 9.8 power 5, you get 90,392. Just because we are estimating and we've not used the full terms in the expansion above, we're supposed to get a slightly different value, just as you can see. But that's how we're supposed to move in such a question. A very good question. Number 12. Now the temperature of a cooling water was measured at intervals of 2 minutes and recorded as shown in the table below. Time in minutes, then temperature in degrees Celsius. The first thing on the grid, draw the graph of temperature against time. Temperature against time. Whenever you are told something against another, the quantity mentioned first should actually be on the vertical axis, and the quantity that comes second should lie on the x-axis. So that's what you're supposed to know whenever you're plotting graphs. Remember that the graphs on rate of change have really been predicted for the Kcse 2025. Some other times the graph is even drawn for you, just for you to determine the rates of change. So please be very careful, be very conversant. Make sure you listen to whatever we teach here after the plotting. Please stay tuned. Remember, you can reach out even for individualized lessons through 07, 04, 15, 33, 66, like that. So let's start now. Temperature in degrees Celsius takes the vertical axis. So we can start with the intervals of, let me check. We're going all the way to 80, the highest value. All the way to 80. So when you use intervals of 10, we shall use up to the last box here. So there is no need. We can use intervals of 20 instead. Yeah, we can use intervals of 20 instead. 20, 40, 60, 80, 100, like that. Then, or we can, let's squeeze it there. Let me just use all the values. Let me use even intervals of 10. 10, 20, 30, 40, 50, 60, 70, 80, okay, for accuracy. Then 0 to 12. So here now we can use 2 minutes, 4 minutes, 6, 8, 10, 12, 14. This is time in minutes. If we use intervals of 1, we will not accommodate up to 12, like that. So 0, 80. Let me plot that. 0, 80, that is the first coordinate. 0, 80. The next one is 260. 260. After that, 446. 446. So 46 is here. Yeah, after 40, 46 is there just before 50. Then 6, 35. 6 goes with 35. 35 is exactly between 40 and 30. 8, 26. 8 and 26. 26 is here. 10 and 20. Then we have 12 and 15. 12 and 15. 12 and 15. That's where 15 is. So we're supposed to draw the graph. You're supposed to join the dots, plotted coordinates using a very smooth curve. A very smooth curve. A continuous one for that case. Smooth curve that was needed in that particular paper. Very smooth curve. Then after the smooth curve, look at what we've been told to find. Determine the rate of cooling between the 3rd and the 7th minute. 3rd and 7th. So we have now to find the coordinates. Whenever we need rate of change between 2 points, we find the gradient at the 2 points. The gradient when you connect the 2 points. So 3 minutes, 3 minutes is here. Let me show you where 3 minutes is. I can use a different color now. Let me settle on this blue. So 3 minutes is in between, exactly between 2 and 4. Exactly between 2 and 4. Then now we read, we check. That is the coordinate that we need. That is the value we need. And 7th, exactly between 6 and 8. That's where 7th is. At that point. So now those are the two coordinates that we need. We get the gradient between those two coordinates. That will be the rate of change. So changing from 3, what is the coordinate there? The coordinate there is 52. 352. And at 7, what will be the temperature? 732. 732. So the temperature is changing from coordinate 352 to 732. So we just find the gradient. So 32 minus 52, that's changing y, over 7 minus 3, negative 20 over 4. That is the rate of change. It's a negative rate of change because it's decreasing. In case you are told to find the rate of change at a point. So let me just give you this note before we proceed. Rate of change at a point, at an instance. We call it instantaneous change. There, draw a tangent at the point and find its gradient. And find its gradient. That will be the rate of change at the point. So rate of change at a point is usually given by, you could have been told to find the rate of change, the rate of cooling at the third second, for example. It means you draw a tangent at the 3rd second, then now you find gradient of that particular tangent. Then when rate of change is between 2 points, rate of change between 2 points, rate of change between 2 points. Find gradient. Find gradient at the 2 points. Find gradient actually using the 2 points. Find gradient using the 2 points, the way we've done using the 2 points. So these are commonly tested questions on rates of change. It's called graphical work, the last topic in Form 3 work. Look at number 13. Please remember to subscribe, remember to share so that you may invite a friend to our powerful broadcast lessons. All right, our lessons here for the November, December holiday are about to start. Kindly book a chance. Book a chance for your friends. Remind them, just advise people about what powerful we have here via Google Meet, very interactive. You can ask questions there. You can respond to questions. We'll be covering the term 1 work of 2026. So you shall be fully equipped by qualified teachers throughout the season. Don't fail to join us for junior school and also the senior school. All right, number 13, ladies and gentlemen. A particle was moving along straight line. The velocity of the particle after t seconds was given by v equals to t squared minus 8t plus 15 meters per second. Calculate the distance covered by the particle between t equals to 1 and t equals to 4 seconds. All right. So now we're supposed to simply say that for us to get displacement or other distance function, we just need to integrate velocity with respect to time. Therefore, now that we need a specific distance between 1 and 4, then we shall integrate the function of velocity, which is a t squared minus 8t plus 15 with respect to time between 1 and 4. So it's a definite integral. So this is for the first value of t, the power increases and the new power divides, minus 8t. The t becomes squared and the new power divides, so 8 becomes 4 because it has been divided by 3, plus 15, whereby t is to power 0 now, it becomes power 1. So we introduce it then a constant, arbitrary constant of integration, 1 to 4. So we substitute 4 in this. 4, where there is t, we substitute with 4, power 3 out of 3, minus 4 into 4 squared, plus 15 into 4 plus c. Then we subtract, when we substitute 1 power 3 over 3, minus 4 into 1 squared, plus 15 into 1 plus c. Okay, let me utilize the space here. In the first case where we substitute 4, we start with 4 power 3, 4 cubed over 3, minus 4 into 4 squared, plus 15 into 4. Now this gives us 17 and a third. Minus, we substitute 1, but it shall now be a third minus 4 plus 15. We get 11 and a third plus c. So now c cancels out because c minus c. Then we have 17 and a third minus 11 and a third, giving us 6 meters as the distance covered there. So the distance covered is 6 meters. Very simple question. Look at number 14 as we wind up. The cash price of a 50-inch Hisense TV is 48,000. A customer paid a deposit of 75,000 Kenya shillings. He repaid the amount owing in 48 equal monthly installments. 48 equal monthly installments. If he was charged simple interest at the rate of 40% per annum, how much was each installment? This is a powerful question, very interesting, and I want you to follow through as you listen to how we are supposed to approach it. You're supposed to know that the balance after down payment has been made, the balance after deposit has been made, usually earns interest, and that is the meaning of hire purchase. You find that the balance, you can't pay it as it was. It has to earn some interest. So let's get the balance first. Immediately, the down payment was made of 7,500. Now, whatever remained became principal. 48,000 minus 7,500. So we have a balance of 40,500. This balance now becomes principal. It is what shall earn interest. So it shall earn interest for 48 months. That is equivalent to 48 months divided by 12. This is equivalent to 4 years. see, equivalent to 4 years. Therefore, we consider it here as 40% per annum per year. So we'll say simple interest is usually given by principal times rate of percentage, the rate of interest times the number of years. So this balance will have earned interest 4,500 times 40% times 4 years. It will have earned 64,800 within the 4 years, 64,800. So what will it have become? The amount. What will this particular customer be paying? The balance it was and the interest it has ended up earning. So this shall be 105,300. 105,300. So at the end of the day, this particular customer will pay, instead of 4,500, will pay 105,300. Now, if this is going to be repaid in 48 equal monthly installments, how much was each installment? So 105,300 divided by the 48 months, that you may know the value of each installment. We get 2,193.75 Kenya shillings. So that is the amount of each installment for the above client. Sometimes the interest earned by this balance is usually compounded. So just read along so that you may know the type of interest according to each question. Number 15, ladies and gentlemen, the area of a rectangle is 48.0 square centimeters and its length is 8 centimeters. Calculate the percentage error in getting the width of the rectangle. One thing that you're supposed to know is that area is given by length times width, meaning that width shall be given by area out of length. Yeah, we just change the subject now to width. Therefore, we're supposed to know this, that area has been recorded to its accuracy of 1 dp. So we can say that if the accuracy is 1 dp, that is 0.1, then we can check the limits within the area, whereby we will say we need to get absolute error in the recording of area. Absolute error in the area shall be accuracy out of 2, 0.05. Then we shall be able to say that the area ranges. The range of the area should be 48.0 plus or minus the absolute error. When we take accuracy divided by absolute error, we get dimensions. We get what we call absolute error. Accuracy over 2. Accuracy over 2 gives us absolute error. So we have the maximum area is 48.05 and the minimum possible area as 47.95. So we have the maximum area and the minimum area, or the upper limit of the area and the lower limit of the area. Then we can also check something called the length. The length has been recorded at 8, meaning that it is to the nearest whole number. If recorded to the nearest whole number, we should talk about 1 as the accuracy. Therefore, absolute error in the length becomes very different because they have been recorded to different accuracies. 1 out of 2, 0.5. meaning that we can get the limits of the length with 8. We add or subtract 0.5. The upper limit of this length is 8.5, and the lower limit of the length is 7.5. So we have upper limit and lower limit in the area, upper limit, lower limit in the length. So with this now, we can work out maximum width. Maximum width. Width maximum. Let's find width maximum. Width maximum requires the highest area, but because it's division, we have to divide with the least length divided by the least length, so that we get a maximum, so that we get the bigger quotient. This is when dividing. We use a numerator which is the biggest, but the divider should be the smallest for the answer to become maximum. So now this gives me 6.407. We can also talk about minimum width. Now the minimum width shall be, we take the least area, but now we are supposed to divide it with the largest length, so that width becomes minimum. We use a small numerator, the smallest possible numerator, but the largest possible denominator. But 7.95 divided by 8.5. This will be 5.641. Then we can now talk about the actual width. Actual width will be given by area out of length as they were captured. We get exactly 6. Now with this, we need to get percentage error. For us to get percentage error, we need to talk about absolute error in the computation. Absolute error is given by maximum minus minimum over 2. Maximum minus minimum divided by 2. Let me work it out once. 6.407 minus 5.641. Then we divide by 2. 0.383. Then after getting absolute error, remember there is absolute error in the computation of these values, and there is usually percentage error when recording dimensions. That's why I talked about absolute error in the recording of dimensions, and I'm now talking about absolute error in computation of the length, the width, that is. So after that, we can talk about relative error, which is usually absolute error divided by actual. Then percentage error is given by relative error, which is this one, expressed as a percentage. So we multiply this by 100 over 6, giving us 6.383. Yes, 6.383%. So that is the percentage error. It's a very interesting question. Whereby at the initial point, we are supposed to understand that width is given by area over length. And we also know that in most cases, people are used to length and width. So that percentage error is found for the area. You are given length and width to find percentage error for the area. So that's a very technical question, and one should be very sharp to understand what it means. Let's try to interpret the question in number 16 as we wind up. Using a ruler and a pair of compasses only, this is on loci, construct triangle ABC such that AB 6 centimeters, BC 5 centimeters, and AC 7 centimeters. So let's start by doing our length AB. We mark point A. Then you stand on the 0 mark. You open your compass. You get 6 centimeters. And after getting 6 centimeters, ladies and gentlemen, you mark on the line here, and you call that point B. Then after that, now, you're supposed to know that BC is 5. So standing at B, you use an arc length of 5, and you just make an arc. You just make an arc length of 5 like that. Then after that, you also know that A to C is 7. So use an arc length of 7, and you also make an arc. So standing at A length of 7, you make an arc. You see the two arcs are intersecting somewhere. That intersection now becomes C, because from C to A, it's 7 centimeters. And from C to B, it's 5 centimeters. So we have our triangle already constructed. Now look at part B now. On the same diagram, draw the locus of all points equidistant from CA and CB. Now, locus of points equidistant from two lines means that you identify where the lines are meeting, AC and CB. These lines should meet at C. Now, the angle at C should be bisected. So we bisect the angle at C so that we get the points equidistant from the two lines. So for points to be equidistant from this line AC and this line, we're supposed to bisect the angle where the two lines meet. So we stand at C, you make arcs. Then standing on those arcs, we make other arcs at this point. Then now you can produce your angle bisector. That's an angle bisector. That's our first loci. That's our first loci. Part 2. Draw the locus of all points equidistant from C and B. Now, locus of points equidistant from two given fixed points means that you bisect the line connecting the 2 points. 2 points are B and C. So you perpendicularly bisect B, C. So standing at B and C, you make arcs on both sides. Then you stand at B and you cut those arcs so that you produce a perpendicular bisector. Perpendicular bisector. Yeah, perpendicular bisector to CB. A perpendicular bisector to BC. So you see, locus of points equidistant from two fixed points. You bisect the two fixed points line, but equidistant from two lines, you bisect the angle between the lines like that. Now shed and locate region R inside the triangle such that the angle ARC and BRC, ARC is greater than or equal to BRC. So the angle from AR then to C should be greater than angle from BR to C, meaning that now we're supposed to identify region R, which is inside the circle. And that region is this one. Let me use a different color to identify. This is the region R, which is supposed to be shaded. I'm shading it with R's inside the triangle like that. That is the region. For the angle A to RC to be greater, we should be beyond. Wait a little bit. No, wait a little bit. Okay, we're talking about AC and BC, sorry, AC and BC. So it's the bisector. We follow the bisector, sorry. Yeah, we actually follow the bisector. We follow the bisector. We follow the line bisector. So these particular coordinates should be here. The values should be here on that region, yeah. On that region. So that, and inside the triangle. So that we talk about, if we are taking an angle AR to C and we want it to be greater than from BRC, then that is what we are supposed to consider. A very good question. 0704153366. That is our consultation line. Feel free to reach out. Thank you. See you another time as we continue predicting the KCSE 2025.